All right, so this unit with data, kind of random, has a lot of stuff that it covers. Today we're going to look at box plots and histograms. All y'all are familiar with box plots. Sometimes you see them box and whisker plots. We did those in 6th grade. Anybody know what a histogram is? All right, so could be overtime. So basically, it's going to look a lot like a bar graph. It's a little bit different, and with a bar graph, usually the x-axis, the horizontal, is like one thing for each bar. Like if I asked y'all your favorite colors, there would be a bar for each color. A histogram has to have like a number amount there, and it might be like, I don't know, if we get all of y'all's weights, we can't list like everybody's individual weight. Like we'd have, 24 different bars going up because all y'all probably have like a different weight by like at least a pound or something like that, right? So instead, what they do is they do a bar graph with a range. Okay, so you'll see in a minute. All right, so let's start with this. If I need a box plot, these are pretty easy to do without a calculator. Okay? So if I'm looking for the numbers on a box plot and I don't have a calculator, or even like I said, in a lot of cases, it's just as easy without one. The first thing you want to do always put your data in order. All right? What the calculator would do is it would save you some time where you don't have to put it in order. But like I said, it doesn't take a whole lot longer. So we got, let's see, 6, 6, 7, 8. Oh, did I miss one? Two 14s. And that's the other problem. I should have been doing like I've said before and checking those off as I go. But you do want to always kind of double check, make sure you didn't miss one like that. All right, so once they're in order, we chop it in half. All right, I have 11 numbers. So what that means is I've got 5 on each side with 1 in the middle. When you have an odd amount of data, there's going to be that 1 exactly in the middle. So if we go 1, 2, 3, 4, 5, let's put my middle here, and you can see I got 1, 2, 3, 4, 5 on the right side as well. What that line there is, that's the median. When we have a median for a box plot, we got 50% to the left, 50% to the right. Then what we're doing is we're chopping the halves in half. So I got 5 here, middle. 5 on the right, middle. So what we have, first quartile. So this is our first quartile. That's the second quartile, but usually they'll just call it the median. And that is the third quartile. Then the only other numbers they really ever ask you for with box plots are going to be your minimum and your maximum. And those are pretty easy to tell and all that. So everybody kind of follow on that? So if we had like an actual like box plot drawn out, what we're looking for is basically the one that has a median at 9, has a first quartile at 7, third quartile at 14. So those would be the lines on the box. And then you're looking for where the whiskers go to 6 and 25. So it would be drawn more to scale, so it'd be accurate. Like our whisker on the right is going to be longer because it's got a longer distance to go to 25. But when you draw it this way, it just all kind of looks even, but that helps you see like where the numbers go. Y'all kind of remember that? All right, so here's the other way. On your calculators, click the stat button. Click edit. And, well, edit under edit, I guess. The categories edit and number 1 says edit. And you need to clear out anything that's in there. we need to put under L1 all the numbers. So go ahead, enter those numbers in under L1. This is what some of y'all were trying to remember yesterday and couldn't. And I didn't feel like telling you, so I didn't. So once you have them all entered in, you hit the stat button again. You move over to calc. And it is, I want to make sure I wrote it the exact way. You got the one variable stats, or one var stats. And then you got to hit enter a few times to get that stuff. All right, so your top number there, the X with the line over it, is your mean. This would be another way you could get mean. If you just have to find the mean and nothing else, though, it's probably almost quicker just to, right? If you go a little bit further down, you see a lot of other stuff, but towards the bottom, you get the minimum, which we had was 6. You get Q1, the first quartile, which was 7. We get the median, we had at 9. Q3 at 14, max at 25. The 5 numbers you would need for a box plot. All right, any questions on that? Y'all remember doing that a little bit at least? Did any of y'all actually figure that out and remember it yesterday fully? Yeah, so when we were working with the mean and all that, you could have done that. All right, so other option, or another option, if you were on Desmos, when you go, you gotta click on the little keyboard. We pull up functions. Under statistics, there's mean, median, minimum, maximum, quartiles, all that. What we want really for this stuff would just be stats. So if you do stats, the one thing that's kind of weird about this is they want you to put like a bracket around the numbers, but then you can enter in the numbers and you can see it gives you those 5 numbers as well. So we got our 6, 7, 9, 14, 25 again. Either one of those works. They work about the same. Same idea. If you got the mean, need a bracket on it, put the numbers in, gives you your mean. There's a lot of other stuff. The non-testing version does even more than that. So this is just kind of what we're allowed on the testing one. Any questions on the Desmos way to do it? I think y'all have done stuff with the yellow graphing calculators more, and using L1 probably is going to be a little bit smoother for most of y'all than using Desmos. All right, so when we have an actual box plot, as y'all know, this is kind of what it looks like, okay? The only numbers that really matter, 5 places. All right, you won't get many other questions than about those 5. The only way you could get another kind of question usually is when they talk about percentages. What percent of the data is right there? 25. So each section, if you remember from 6th grade, that's 25% of your data, okay? Interquartile range, anybody remember what that means? All right, who can give me the answer for this one then? Ryder? Yes, but no. You gotta subtract them. Right numbers. So you said 60 to 145. That is where the interquartile range goes. When it's asking for that range or the interquartile range, you gotta actually do the subtraction though. Like we did range yesterday, that was max minus minimum. This is Q3 minus Q1. Okay? All right, so sometimes Math 1 asks you some stuff that sounds kind of weird or sounds a little different. So we got this one here. It says 2 outliers will be added to the data set displayed out on the box plot. One outlier is 1.5, the other is 456.5. How will the median be affected by the outlier? Anybody got a guess on that? It'll go up, you think? Anyone else got a guess?
It won't move.
Yeah, it's not moving at all. All right, so what's the median? Well, what's median mean, the term? The middle number, okay? So I don't feel like using those numbers. Let's just go kind of easy. We go 2, 3, 4. What's my median? 3. If I add one higher, one lower, right? What's my median? 3 still. So same idea here. If we add one that's like crazy low and crazy high, we're still right there in the middle, right? It doesn't change anything. If you add just a high one, it probably will get a little higher. If you add just a low one, probably get a little lower. The mean in this case would definitely go higher because that 456 is way higher. And that 1.5, while it's lower, isn't like as huge a difference. So the mean would go up, but the median would stay the same. Make sense? All right, so the other thing sometimes you get are ones like this, where it compares more than one. So this one even has 4 different box plots of people that manufacture bricks. So what we're looking for is which one of those has the highest median. Edwin? Bob is the highest median. So our medians is the middle of the boxes. So when you're looking for the highest median, that's all you're doing, is looking for the highest one of those. All right, so there's different things this could tell you. If you're looking for the brick company, I guess, that is the most consistent, you want the one that's got like the most narrow from maximum to minimum. That means most of their bricks are going to be in that same range. They're going to be closer and closer to the same size every time. So that's another way they can kind of look at that stuff. Oh, whoops. Forgot about that one. So contractor needs to buy bricks that are each as close to 2.5 as possible. So if we're looking for 2.5, that's right there. And like I was saying, you want the one that's kind of closest and most consistent to it. The one that's tightest to that is Daniel's bricks. That's how that one would work. Even though the median for Adam's bricks is just about right there. That makes sense? Sorry, I forgot that question was there. Anyhow, this is a histogram. Okay? Y'all see what I'm talking about? It's exactly a bar graph. The only difference is that x-axis here shows a range each time. All right. Y'all, sometimes it's this easy. Or hopefully this is easy. 3 is correct. Sorry, I couldn't hear you. We got 60 to 64. That's at 3. All right. Not everything has to be difficult or has to be a whole lot of work. All right, so we'll make it a little tougher. Students are under 5 feet tall. Brian? 6. All right, so a couple things we got to do. The height's in inches. So 5 feet tall is how many inches? 60. All right, so we're looking for less than 60. That's these 2 columns right here. So that means we got a 2 and we got a 4. 6 of them are less than. Okay? Did I put the same thing to what? Yes, I did.